Good morning, student. Today we will discuss about the new content that is bearing. Okay. So, what is bearing? Actually, bearing means it's a part of any component that bear the machine element load. Okay. So that means it support it any kind of axial or radial kind of load, especially radial load, but it partially support the axial load also. So what is the function of bearing? The main function of bearing in rotating shaft is to transmit power from one end to another end, and it need a good support to ensure the frictionless rotation. Okay, the shaft has to be running fit in the bearing so that all bearing are provided some lubricant arrangement. Most cases, otherwise there would be a chances of wear or tear on the shaft or other rotating parts. Okay, so if we talk about rolling contact bearing are also called anti-friction bearing. Okay, in sliding contact later on in next class we will discuss about another topic, that is sliding contact bearing. In today's class we will discuss about rolling contact bearing. In rolling contact bearing are used in radial load, as I said, thrust load and combination of both the loaded, okay, condition. These bearing are extensively used due to the relatively lower price and being almost maintenance free. So again, roller contact bearing are subclassified into two category, broadly two category. One is ball bearing, another is roller bearing. Okay, so when we use a rolling contact bearing, when low starting and running friction is needed, accuracy of the shaft alignment needed. Okay, and where cost is a primary consideration, and all other cases we consider rolling contact bearing. Here are some types of rolling contact bearing I have shown as I this is the ball and this is the roller. Okay, here in roller bearing a roller is used in between two housing, and here a ball is used. Okay, so here this is the this and these are the races, this is the outer races, these are the inner races. So one axial thrust, in some books it so radial thrust, it could it some book it mentioned by PR and some book in WR. So this is the radial thrust applied over the bearing due to the um, load it bear. Okay, and this is the axial thrust or axial load of the bearing material. So here you see that the cross section has been shown for uh, roller. This one is roller bearing and this one is a ball bearing. Okay, here number of ball are used, which are surrounded by the racing. This one is the outer, this is the inner racing, and so this is the bore diameter where the shaft is normally placed. Okay, so actually these races and balls are high carbon chromium steel because we need high anti-corrosion resistance. Okay, so this must be high chrome steels. Okay, and the case that made up of low carbon because and bronze yeah, things materials, because in cage um, only it support the cases. Okay, maximum load is beared by the ball or roller. Okay, so it must be high strength, high corrosion resistance materials. Now in ball bearing, this is important in your syllabus, deep groove ball bearing, and they are primarily radial. As I said, they bear both radial as well as axial load. In deep bearing, I think are classified into two categories. Those are if there is a two row and one is a single row deep groove bearing. Okay, this is a double row so that it can bear more support, more load. Okay, and next is angular contact bearing. Here, whatever in this figure, you will find that this outer race and inner race both are placed at a certain angle. Okay, they are not horizontal position. Okay, in some cases this kind of ball bearing are also used. You will see that the uh, both the outer ring as well as inner ring has some inclinations. Okay, so actually this contact angle may be in between 10 to 45-degree angles depending on the application. Otherwise more than 45 there will be chances of sliding. Okay, and the life of the bearing material will reduced. Now, another types of ball bearing is thrust ball bearing. I- Okay, in thrust ball bearing, it's a particular type of bearing. Like rotary bearing, they permit rotation between the part, but they're designed to support the axial uh, load. In these cases, you will find that the load are applied in this direction. Okay, in some cases load are applied in radial direction. That means the support over this material. Okay, in these cases the load applied in this direction. Okay, so this is just depending on the load capacity, load type, these bearing types are varied. Now come to the roller bearing. This is the needle bearing. Number of needle type bearing, long thin needle type roller bearing is support the load. Okay, and then come to the tapered bearing. Here all the roller bearing are placed in a taper position, so that some of the axial thrust load and some of the radial load, okay, both component can be bear together. Now cylinder roller bearing used for thick and long cylinder like leaden bearing. It's a very thick in Italy and long cylinder are used in this type of bearing. You will see that this is a cylinder type bearings where the cylindrical roller, okay, cylindrical shape roller are used in both the directions. Okay, now radial ball bearing has different types. Single, again single row, here only a single row deep grooves. Then there is a notch. Okay, in this side there is a notch, and and uh, and then angular contact bearing. It looks like a single groove bearing, but this lower race and outer race, this has some inclination, angular contact bearing. Then double row, then self engaging. In these cases there is a no chances of come out the ball from these races. Okay, and Okay, this is a very basic cases. Here we will see a typical ball bearing. You see that the ball, this is the steel ball, mainly chrome steels are used. Sorry. Sorry. This is the inner diameter, where the shaft is placed, and this is the outer diameter of the bearing, and this retainer is placed to hold the ball in a perfect place so that there is no disalignment of bearing. Now, they this roller bearing have consist the following parts. One is inner ring. This is okay. This is the inner. There is an inner ring. There is a outer ring. Okay, this is the outer ring. This is the ball. Inside the one is inner ring. Outside one is the outer ring. Ball or roller. In some cases, ball used. In some cases, roller used. Okay, and the case. This is the and the case which support the ball in a roller position. Okay, so here are some principal dimension of roller bearing. If the depending on the bearing numbers, if you go to market, they'll ask for a their bearing number will mention. By following this chart, you can find the what will be the bore diameter of this bearing, what is the outside diameter, and the width of the bearing. This is just normal cases only. Okay, bore diameter, this are the condition you can find only by this number. So next is types of roller content bearing. We already talked about ball bearing. Now let's talk about roller bearing. The cylindrical roller, spherical roller, needle roller, and taper roller. Different kind of roller are used. I think I have sorry, needle. Okay, I have discussed these things. Okay, now let's talk about load condition. As I said, there is a mainly two kind of load are applied over the bearing. One is radial load in the radial direction. This will support the total load and the axial load. Okay, in some cases axial load also, the mostly it's bear radial load. Okay, so bearing load, um, here important things that we need to find is bearing life. What is the life of any bearing ring? Okay, and the bearing speed and accuracy. Bearing life of an individual ball or roller bearing may be defined number of revolution. In cases, in some cases, it will be in revolution. In some cases, it will be in hours. Okay, so we can use both the formula depending on the what type of question asked in the university question papers. Okay, so if it is L10, L this number L10 means it's a millions, in millions of revolutions. Okay, it's life in 1 millions of revolutions. Okay, um, now here different kind of instruments and they are in bearing life. In some conditions, you may need to assume if bearing life is not given in some cases. In that condition, they will mention what kind of purpose, what purpose this bearing is used. In that condition, this chart is needed. Okay. Now this is the formula to calculate the bearing life. Okay. Uh, and where this is if you uh, this formula is very important. C10 is the catalog rating. Okay, and this in some cases this you need to find. Other all condition will be given in the formula, or in some problem catalog rating will be given. So by following that number, you can find the other unknown conditions. Okay, and this is the LR is the rating life in hour, and this is the rating speed. Okay, uh, and FD is the desired radial load. Okay, it could be on pound or kilonewton, and LD is the desired. I have given a problem so that you can easily understand these things. Okay, yes, C10, if asked for catalog rating, you can find the this equation. This equation come from these relationships. Okay, here I have given a simple problem. Select a deep groove ball bearing for a desired life of 5,000. So LD is given, right? And at 1725 RPM, that means N also given. Okay, ND and LD both is given. Okay, or not, whatever. So with the reliability of 90%. Now the bearing radial load also given. So FD here, FD is given, LD and D, these all things are given. Okay, and we have to find the uh, rating. Okay, which rating it belongs to. Okay, so by applying this formula, we can easily find the rating. Okay, so if it's reach beyond 14 point something, so we have to take next rating for safe design. Okay, because it's a 14.3, so we cannot consider 14 rating. Okay, we have to consider the next to 14, because in if you take 14, there is a chances of failure in the bearing earlier. Now static load and dynamic load condition, actually some of the symbol or terminology you need to know. That one is as a C dynamics load capacity. C, this is C0, C is static load capacity. Then axial thrust. Okay, axial thrust is FA or WA. Okay, whatever. And then radial thrust, that is FR or WR. Then L10, which just now we mentioned. L10 is a rating in life in millions of revolutions. Okay, uh, in some books it refer L10H. L10H means in hour. It given in hour, then life in hour. L10H, this is the another term. This terminology is very important during bearing type problem solution. Okay, then the static load capacity. Okay, then dynamic load capacity, that is P is the equivalent. Okay, equivalent dynamic load capacity. So if there is a number of bearing load, okay, W1, W2, W3, then equivalent with the P. Okay, and P is the if it is denoted in cycles, okay, then it will be the PC. Okay, and some other terms is reliability is important. Okay, reliability and in L or L10, depend on the situation, reliability on L or L10. And then race rotation factor, these are the terminology important. Okay, I'll discuss later on. Okay, now basic static load. This is important. C0, this is C0, basic static load rating. Okay, that C0, C0, these are important terminology. Okay, so what is this? Is defined as the static radial or axial. Suppose the bearing is in rest, not in running condition, then it will have some capacity. Okay, so actually the property which needed for bearing material, we need to know these things. One is fatigue, corrosion resistance. Okay, then compressive strength. These three properties very important during selection of bearing material. Compressive, because it's bear compressive load, so compressive strength is important. Then wear resistance is very important, another. And another is corrosion resistance or resistance. uh, Another is fatigue, because it's bearing used for long time okay. So after Sunday there is a chances of fatigue failure on the ball. Okay, so fatigue failure is mostly due to the static load. Okay, so is define the static radial or axial load, which corresponding to the total permanent deformation of the ball or race at the most heavier stress contact conditions. Okay, um, and equal to 0.0001 times of the ball diameter. Okay, so here in usually it will take. So here you'll this is for radial for different bearing material. If it is a radial ball bearing, then you use this condition. If it is thrust ball bearing, we use this condition. If it is roller ball bearing, we use this condition. If it is thrust roller ball bearing, then we'll this equation. Okay, so C0 is equal to F0 I Z d square into cos theta. Okay, sorry. If there is any inclination, means in nominal angle contact, then cos alpha will come. Otherwise, it will be cos 0 equal to 1. Okay. So, okay, so F0, first of all, F0 is the factor that depend on the what kind of bearing material you have chosen. Okay, resistance factor. Then this is the number of row, how many rows, if it is a single row ball bearing or row ball bearing, depend on the I is a number. Then Z, there is the number of ball in per row. In single row, how many ball are used? Okay, that is the jet, and this is the diameter of the ball. So depending on these things, the static load capacity um, rating will depend. Same similarly for thrust bearing, roller contact bearing, and thrust roller contact bearing. Okay. Okay. Now, static equivalent rule for roller contact bearing. Okay. For roller contact bearing, that will be the uh, this is the radial load into a radial factor, then axial load into a axial factor. Okay. So it will find from here static factor rating. Okay. Okay, these are the factor. Okay, depending on the angle of contact of the group, you will choose this factor. If it is a if it is a single row bearing, we will follow this chart. If it is a double row bearing, we will follow this chart. Okay, this is the factor. In most cases, it will be given in the problem. Okay. Now, static equivalent radial load. Okay, that in cylinder roller bearing case, it's a all OR equal to means WR equal to WR. Okay, these are the other condition that will, okay, dynamic equivalent ruling capacity. This is another important after statics. In dynamic, that means after X or W, another term will count, that is the rotating factor. Okay, this V in static load, W equal to X into WR, Y into WA, but in dynamic load, X into V into WR. So dynamic rotating factor will come. Okay, and This is the dynamic load ratings of the roller contact bearing. This is the equation. Okay, so L equal to, this is the life, L equal to C by W, where C is the basic dynamic load factor. Okay, C0 is the statics. Okay, and C is the dynamics. Okay, load factor, and by W is the dynamic load. Okay, equivalent dynamic, we have to find equivalent dynamic. We'll take a problem so that it will be easy for you to understand. Okay, now so from this equation we can calculate the basic dynamic load capacity factor. Okay, so reliability. Okay, reliability means the ratio of number of bearing which successfully complete number of millions of revolution. Suppose it will complete L revolution in total number of bearing under test. Okay, so it becomes necessary to select the bearing having reliability of more than 90%. This, okay, is it just a terminology? So reliability isn't important in your cases right now. Okay, let's talk about the materials. Materials I have already discussed that in mainly chrome steels are used. Depending, lubricant isn't important. We'll discuss these things on sliding contact bearing next classes. Okay, and finally, these are the things important to solve a problem. First of all, life of a a roller bearing or ball bearing. So L equal to C by W. These are I already discussed. Where L is the life rating, okay, and C is the basic dynamic load capacity. W is the equivalent dynamic load capacity. Okay, K is a constant. Okay, depending on the ball bearing and load bearing, it will vary. If it is ball bearing, we generally consider it is 3. If it is roller contact bearing, K we consider 10 by 3. Okay, and L is 60 N, means N is the number of revolutions. So here we can consider the revolutions in hour also. Okay, and so fraction of life consumed with load W1 acting on the acting for n1 number of revolution, then this relation we will use. These are the actually one by one, these relations we will use to solve the any kind of problems. Okay, next is the equivalent constant load to find the number of revolutions. Okay, same formula. I just changing the um, direction. Okay, if it is C, if it is N, it is W. Same formula we using depending on the conditions asked for. Okay, so if there is a number of load, okay, W1, W2, W, depending on that, we find equivalent load capacity. Okay, and finally, is for statics. If it asks for statics load, we use this formula. If it is asked for dynamic loads, this will come. Okay, and this V factors is 1. Okay, when inner race is rotating. Okay, if it is 1.2, then all type of bearing except self engaging inner. Okay, when inner race is stationary. So if in the this kind of things will mention in the question. Okay, so that you can. Okay, thank you all. I'll give one assignment on Google Classroom so that you can easily solve only by following this condition. This 10 condition you can solve that problem. Okay, thank you.